So a little bit more on Newton's first law, which I'll abbreviate as NFL for Newton's first law. It regards resultant forces, which is the sum of the vector forces acting on an object. So force is a vector quantity. So if you sum up the forces in vector form and you get 0, so adding the vectors gets you nothing, so all the I components equal 0 and all the j components equal 0, you have therefore no resultant force. So Newton's first law regards what happens. So yeah, if the sum of 0 is along a particular line of action, then the object is either traveling at constant velocity, because if there's no acceleration, then it's just traveling without changing speed, or motionless along that line of action. Now, a line of action, I will confirm in the next slide. However, it's just a bit like an axis. So, if we have a point mass, say, and there are two forces acting like this, well, they have to be, well, assuming they're perfectly straight, the axis that it's running through, so this green line, is its line of action. Similarly, if we have two more forces, then their line of action now is this blue line. So it's essentially the axis that forces in a certain direction are acting on. A way that we've previously demonstrated this is with a projectile. Because we haven't covered projectiles with air resistance at this stage, we've assumed that there's no air resistance, and if there's no force, there can't be an acceleration, so it travels at constant speed, or the velocity in the x direction travels at a constant speed. So the velocity in the x direction, let's switch to red. So the velocity in the x direction is always the same as the initial velocity in that direction. Whereas the velocity in y, because we have gravity, is uy minus gt. But that's an example that we've already gone through. Here we have a block with two 50 Newton forces acting on here. We said in chapter 1, or chapter 1 rather, that the unit of the force is the Newton from one of the first videos on dimensional analysis. So that should be at least a bit of common knowledge at this stage. So these are acting along their line of action. So this is like their axis per se, their line of action. One of them is pulling 50 newtons the other way. The other one is pulling 50 newtons opposite to this. So this would be 50 newtons in a positive x direction, and this would be 50 newtons in a negative x direction. So adding up the forces, the vector forces, you'd get 0. So either this is traveling at constant velocity, or it's completely motionless. This 50 Newton force could be friction or air resistance, but either way, it's not moving, or it is moving, just it won't change acceleration until one of these forces increases in some form or another.